Okay, so in this video, we'll be covering quadratic equations and quadratic inequalities. This video is part of functions of IB, AHL, and SL. And this video will include quite a few things, and I have them listed right now. So we're gonna have three methods how to solve a quadratic, and the quadratic formula, and then discriminant and quadratic inequalities. So this might be a long video, so you guys can skip to whichever part you need to focus on more. Okay, so first let's start with solving by factorization. This one is probably the most common method of solving a quadratic if you're given, if you don't have a coefficient for a. So let me tell you what I mean. Let's look at the general form of a quadratic. So we know it's ax squared plus bx plus c. So this is the form of a general quadratic equation where a, b, and c are all real numbers. Now, a solution to the quadratic equation is basically a value of x for which the equation is true. So let's look at an example. Let's say we have x squared minus 5x plus 6 is equal to 0. A solution, what we're looking for is basically value or values of x. This is 6, by the way, not c. For values of x for which this equation is true, so for which this equation would equal 0. So when x is equal to 3, let's substitute it in and see if this works. So 3 squared minus 5 times 3 plus 6 is equal to 0. And let's see if this checks out. 9 minus 15 plus 6 is equal to 0. 15 minus 15 is equal to 0. And so basically what this means is x equals to 3 is the solution to this equation. Now let's look at when x is equal to 2. If we do 2 squared minus 5 times 2 plus 6 is equal to 0. 4 minus 10 plus 6 is equal to 0. And so 10 minus 10 is equal to 0. So this also proves that x minus 2 is also a solution to this equation. Now, when we have a quadratic, or let me just tell you guys something. When we have a quadratic, the highest degree of x is 2, right? Because it's always just going to be x squared for a quadratic. When we have a cubic, so quadratic x squared. When we have a cubic, x cubed. When we have x to the power of, then we have x to the power of 4, x to the power of 5, so on, so on, so on. So these degrees can keep increasing, right? And just something to keep in mind for you to know how many solutions an equation can have. If it's a quadratic, it will always have 2 solutions. If it's a cubic, it will have 3 solutions. And if it's with a degree to the power of 4, it'll have 4 solutions, and so on, so on, so on. All of these solutions may not be real. Some of them may be complex, or they may be like 2 of the solutions would be the same value. But if you graph it, there technically are 3 points at which this equation would intersect the x-axis. And if this is a bit confusing, let's say we have this and we have a quadratic. A solution is basically when the graph meets the x-axis. So that's basic, it's called a root. So in a quadratic, it will have 2. In a cubic, which looks something like this, it will have 3. And obviously, if it's linear, it just has 1. So if it's x to the power of 1, it will just have 1 solution. That's just something that you guys should remember just to have a good idea of how many solutions an equation can have. So what this means is, therefore, 3 and 2 are roots to this equation. So the first thing that's a bit important for us to know is called the null factor law. What this basically means is that if a times b is equal to 0, then either a is equal to 0 or b is equal to 0, or both a and b are equal to 0. So when one of the coefficients b or c in ax squared plus bx plus c is equal to 0, the quadratic equation is basically easier to solve. So let's look at what I mean by that. Let's consider ax squared plus bx is equal to 0. In this case, c is 0, so we don't have to write it down. If we factorize it and take x common, we get ax plus b is equal to 0. And so applying the null factor law, we can say that x is equal to 0 or ax plus b is equal to 0. Basically, if we have it in two different, if we have it in like factorized form and there are two different brackets, we can use the null factor law saying that either this is 0 or this is 0. And we're finding out which. But obviously in this one we already know that x is equal to 0. Or x is either equal to 0 or x is equal to minus b over a if we solve for x. And that's basically how you use null factor law. And this is with obviously the variables, but we'll have a look at a proper example right now. Okay, let's look at an example. Let's say we have a quadratic equation 4x squared is equal to 2x, and we need to find the solution by factorization. So what we can do is first bring rearrange the equation so that all the common terms are together. So we'll do 4x squared minus 2x is equal to 0. Important note is do not divide by x. Don't ever divide by x in any situation. So in this case, if we were to divide by x, it would become 4x is equal to 2, which would be incorrect. That would only give you one of the solutions. We need to find both. So if we divide by x, we're automatically eliminating one of the possible solutions. So do not divide by x, bring all the terms to one side and factorize. So then what we can do is take 2x common and get 2x minus 1 is equal to 0. Apply the null factor law, we get 2x is equal to 0 and 2x minus 1 is equal to 0. This way x is equal to half and x is equal to 0. So now we have our two solutions for this quadratic. If we were to divide by x, we would only get this one. We would not have gotten x is equal to 0, which is the other root. And this is extremely important in all concepts, to never divide by x. Okay, let's look at another example and another shorter method. I'm going to teach you about factorization. So let's say we have x squared is equal to negative 7x minus 12. First step, rearrange and bring everything to one side. We need to get it in the form of ax squared plus bx plus c. So if we bring it all to one side, we get x squared plus 7x plus 12 is equal to 0. Now you might be a bit confused as to how we can factorize this because we can't really use x because there's no x value with 12. So what we do in this case is make two brackets. And what we have to find is two numbers two numbers that will multiply to give us 12, and the same numbers that will add or subtract to give us 7. And we need to find these two numbers, right? And the way we can do this is we look at factors of 12. So what do we know? What multiples do we have of 12? We know there's 4. Well, we know there's 6, right? 6 times 2 is equal to 12. But is 6 plus or minus 2 equal to 7? No. 6 plus 2 is 8, and 6 minus 2 is 4. So this won't work. Let's look at 4 and 3 is equal to 12. But is 4 plus or minus 3 is equal to 7? Yes. 4 plus 3 is equal to 7. Therefore, these are the two roots of this equation. We've simply found the two roots. Again, it's when the two numbers multiply to give you the C value and add to give you the B value. So what we can do now is write this as x plus 3 and x plus 4 are equal to 0, right? So that's basically what when we get 4 and 3, we write it in these two brackets. And we get it as, when we factorize them, this is what we would get. As in when we factorize x squared plus 7x plus 12, we would get x plus 3 and x plus 4. This is just a quicker way of doing that, right? And so from this point, what we can do is, we know that now x is equal to minus 3 and x is equal to minus 4, because this equals to 0. And now we can use null factor law and say x plus 3 is equal to 0, so therefore x is equal to minus 3, and x plus 4 is equal to 0, so therefore x is equal to minus 4. This is another way of factorizing. It can take a little bit of practice, but I hope you guys understand. I'll just write down the multiplication and addition thing. But keep in mind, this only works when coefficient of a is 0. We need to make sure that there is no a value before x squared for this method to work. If there is, and there's a way to eliminate it, like by dividing it off on each side, that's fine. But if there is an a value, let's say we do have 2x squared plus 5x minus 7, we can't use this method. We can't find two numbers and only relate it to this one. That uses a different method, which we will look into now. Okay, so let's look at an example where the coefficient of x squared is not 1. So in this case, we have 2x squared plus 7x plus 3. And we can't initially use the same method that we did about finding the pair and putting it directly into the two brackets and solving. We can't do that. Because we have a coefficient of a here, a coefficient of x squared, which basically means the a value, which is not 1. And previously I know I wrote down that when a has to equal to 0, I actually meant 1, and it doesn't make sense if a is equal to 0, because that means there would be no x squared value. I meant when a is equal to 1. So when a is not equal to 1, this is what we do then. Okay, so what we have to do now is we have to multiply the terms a and c. We have to multiply 2 and 3, and we get 6. Now what we have to do is with 6, right, we have to find two numbers that multiply to give us, excuse the spelling, that multiply to give us 6, and add or subtract to give us 7, because 7 is the b value. That doesn't change. We just take the product as the product of the value a multiplied by c. Now, The only option we have that's gonna, of the two numbers that's gonna multiply to give us 6 and add to give us 7 is 6 and 1. Because 6 times 1 is 6 and 6 plus 1 is 7, which is what we need. So now what do? Now we basically substitute this 6 and 1 that we have into 7x plus 3. Let me show you how that's going to work. So our 2x squared stays the same. So we go 2x squared, right? And then we go plus 6x plus 1x plus 3. This also stays the same, sorry. The c value also stays the same. We basically expanded the b value because, let's think about it. 6x plus 1x is 7x. So we've basically split the b value into something that will allow us now to factorize these two as their own pair, which is really interesting because look what we can do now. We can take 2x common from here and get x plus 3, and over here we can just take 1 and get x plus 3. Now what we have is we have the same factor, and what we can do now is we can combine this and keep our common factor. So what we can do is now 2x plus 1 multiplied by x plus 3 is equal to 0. And from now we can use the null factor law, which we know is 2x plus 1 is equal to 0, so therefore x is equal to negative a half, and x plus 3 is equal to 0, so therefore x is equal to negative 3. And that's how we solve for when the coefficient of x squared is not 1. I would suggest that if factorizing is possible, go for it. Like, the next methods that we're going to do are important, but if factorizing is a possible option, it most likely will be the quickest. So just go for it. Okay, so the next thing we need to know is solving by completing the square. And this is basically when we transform the quadratic function from general form to vertex form. And if you don't know what general versus vertex form is, we did cover it in a previous video. You can go watch that one where it was introduction to quadratics. So basically it's the same method for equations that cannot be easily factorized. So the basic idea is to convert from ax squared plus bx plus c equals to 0 to the form a times x plus p squared is equal to q, which contains just a squared term and a constant term. The solutions, when you have it in this form, are easy to obtain. So let's look at an example. Let's say we have x squared plus 6x plus 2 is equal to 0. And we need to rearrange the equation so we get the constant term on the right-hand side. So we get x squared plus 6x is equal to negative 2, right? And now, and the most important step is to add b by 2 squared to each side. Because obviously what we do to one side happens to the other side. So in this case, we'll do x squared plus 6x plus 6 over 2 squared is equal to minus 2 plus 6 over 2 squared. And we'll follow up here. So to rewrite the expression, we'll get x squared plus 2 times 3x plus 3 squared is equal to 9 minus 2. And so now we can recognize the left-hand side as a perfect square. So what we can now write this down as is x plus 3 squared is equal to 7. Because if we were to expand this, it would be x squared plus 6x plus 9. But we just kept it shorter and put it in terms of 3. But either way, it is x plus 3 squared, right? And now, if we take the root of both sides, this gets cancelled out. We get x plus 3 is equal to plus or minus root 7. It's important to keep in mind the plus or minus because obviously a square of a negative number will still be positive. So we need to put plus or minus. So when we finally solve for x, we get x is equal to minus 3 plus or minus root 7. So that's the solution. Roots of x squared plus 6x plus 2 are negative 3 plus root 7 or negative 3 minus root 7. And this is what we do with completing the square. We have to add b by 2 squared to each side. Okay, so next we're going to talk about solving a quadratic by graphing. And this can 9 out of 10 times be done on your GDC, where you just have to plot the quadratic and solve for the x-intercept. So plot the quadratic and solve for x-intercepts. And whatever the x-intercepts are, once again, they're called roots, is your solution to the equation. With graphing, it's pretty simple because let's say we have a graph that looks like this. Okay, and we have a quadratic. Whatever these points are, the two circles, that's the x-intercept, and that's the root to your equation, and that's the solution to your quadratic. That is it for graphing. You need your GDC, and just simply the calculator will find the x-intercepts for you. The last way we need to know is solving by the quadratic formula. Now, so the quadratic formula will help you solve any quadratic ever. It does not matter if it can be factorized, if it cannot be factorized, if you can use completing the square. Any quadratic in the world you can solve with this formula. And sometimes it's really handy if you're quick with it, but it can be time consuming. And sometimes the question specifically asks to factorize and this and that. But anyway, the formula is negative b plus or minus root b squared minus 4ac over 2a. And these variables, of course, are from ax squared plus bx plus c. So you just plug in the values into this formula and you will get your answer. Let's say we have 4x squared plus 2x minus 9. This is your A, this is your B, and this is your C. Plug it in to this formula and solve for 0, of course. You will have your two answers. It's kind of the golden key to everything. If nothing's working out, if you cannot find a solution and you don't have a calculator, just use the quadratic formula. Okay, so the next thing we're looking at is discriminant, and this basically is derived from the quadratic formula itself. So as we just saw, the quadratic formula is negative b plus or minus root b squared minus 4ac over 2a. It's also really handy to just memorize this because you don't want to keep going back and forth from your formula booklet. But anyway, the portion that's under the root, which is b squared minus 4ac, is what's considered the discriminant. So we can rewrite the quadratic formula in terms of the discriminant by saying negative b plus or minus root delta over 2a. And delta is something we represent for discriminant in math. So there's 3 cases with the discriminant. The first case is if b squared minus 4ac is greater than 0, and this means that the quadratic equation that you have will have 2 distinct roots. If b squared minus 4ac is equal to 0, that means that there is a repeated or double root, meaning both the x-intercepts of this quadratic is at the same point. And when b squared minus 4ac is smaller than 0, it means that there is no real roots or complex roots. And we'll understand what complex roots means a bit later. But these are basically the 3 main cases to understand the nature of our quadratic. The main purpose behind the discriminant is for us to find out the nature of the quadratic, whether it has 2 distinct roots, a repeated root, or no real roots. So the last thing we need to know in this video is inequalities, and quadratic inequalities are pretty similar to any other quadratic, but we just need to keep in mind the range of values for which the root is valid for. X squared is greater than x plus 2. That's an inequality, right? Because it's not using an equal sign. But we still follow the same method and pretend for now that the inequality is an equal sign. So what we can do is rearrange and get everything to one side. X squared minus x minus 2 is greater than 0. And factorize, which would be x minus 2, x plus 1. Over here we can use the method where we think of 2 numbers that multiply to give us negative 2 and add to give us negative 1, which is negative 2 and 1. And we can still keep this as greater than 0. So basically the corresponding equation to this would be x minus 2 multiplied by x plus 1 is equal to 0. That would be our equation if we were using an equal sign but instead of an inequality. Now, the roots of the corresponding quadratic equation, which we just saw, were 2 and negative 1. So now what we can do is, I'll put the equation back. X minus 2, x plus 1 is equal to 0. If we have this, okay, we can make a table. Okay, so this would be our x. This would be x minus 2, x plus 1. And this would be x minus 2 multiplied by x plus 1, right? This would be negative infinity, positive infinity. This would be negative 1 and 2. And the reason this is negative 1 and 2 is because this is the roots that we just found with these 2 brackets. So now what we can do is basically test any point from this range, from this range, and from this range. So from negative infinity to negative 1, if we take any number, okay, let's say we take negative 5. Negative 5 minus 2 would give us a negative number. So therefore, we're going to put negative here. If we take it for x plus 1, we will get also a negative number. And if we do the same thing for something between negative 1 and 2, you can usually just take 0 because that's the easiest option. We should go for the easiest test point. So if we take 0, we get negative here, positive here, and obviously from 2 to infinity, everything's positive. So it would be positive, positive. So now when we multiply these 2 together, right? Negative, negative makes a positive. Negative, positive makes a negative. 2 positives stay positive, right? So what we can identify from this is that the inequality is valid from, we know the positive is from here and here. So this is our range. And when the x value is between negative 1 and 2, we get a negative answer, which is not true. Which, I mean, we can't have as a root. So what this means is x is smaller than negative 1 or x is greater than 2. this is how we would write our quadratic inequality solution. Now, if we had this equals to sign, it would just be x is equal to 2 or x is equal to -1. But when it's inequality, we kind of need to think of it on number line as for which values it is possible for, because it's not only 1. Like if x is smaller than -1, it's valid. If x is greater than 2, it's valid. So this is the process of how we can solve quadratic inequalities. And yeah, that's pretty much it. And that also wraps up the content for this video. We will look at a few examples of IB style questions related to the topics that we just covered right now. Okay, so let's look at this first question that we have. Let's solve it. It's a pretty easy question. And let's look at part A, is to write down the y-intercept of this. Really simple. It's obviously -8. Part B, solve the equation f of x is equal to 0. So this is basically asking us to factorize and solve. Now we can do two numbers that multiply to give us 8 and add to give us -2. This would be -4 and +2. So x minus 4, x plus 2. So we get x is equal to 4 and x is equal to -2. And that's the solution. Part C, we have find the equation of the axis of symmetry to the graph of y equals f of x. And the equation for axis of symmetry is -b over 2a, which is -2 over 2 times 1, which is 2 over 2, which is 1. So the equation of the axis of symmetry is x is equal to 1. And these are our answers for this question. Let's look at another one. Okay, let's have a look at this question. This one does use the remainder theorem, which we will look into a bit later. I can explain what it means briefly. So this question says that when p of x is divided by x minus r, the remainder is 3. Given that they're all real numbers, find the largest possible value for c. So when we look at remainder theorem, we can say if we substitute p with r, we're going to get 3 because that's the remainder, as they said, right? So if we substitute basically p with r, we get 2r squared plus 4r plus c is equal to 3. And if we rewrite this, we'll get c is equal to -2r squared minus 4r plus 3. And now what we can do is kind of a factorizing method for these two values here. So what we can do now is c is equal to -2 of r squared plus 2r plus 3, right? We took 2 common and factorized it, and we can factorize this further and get r squared plus 2r is basically r plus 1 squared minus 1 plus 3. Okay, we expanded whatever was inside the brackets further, and what we get is -2 r plus 1 squared plus 5. So this is factorizing and completing the square at the same time, as you can see. We basically found a complete square with r squared plus 2r. And so the largest possible value of c is when r is equal to -1, because that would make this whole thing 0. So the largest possible value of c max, has to be 5. So yeah, that's it for this video.